Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, a researcher found that the level of antacid in a person's stomach T minutes after a certain brand of antacid tablet is taken is L at T equals 6T over T square plus 2T plus 1. So in part A, we have to determine the value of t for which prime of L at t is equal to 0. So for part A, the first step is to find the derivative of the given function L at t. Now L at t is a rational function, so we'll have to use quotient rule to find its derivative. So for part A, the first step is prime of L at t equals, so as per the quotient rule, we start with the derivative of the numerator. So the derivative of the 60 term is just 6 times the denominator, which is t squared plus 2t plus 1, and then minus the numerator expression, which is 6t times the derivative of the denominator, which will be 2t plus 2. So we're using the power rule. So the derivative of 1 is 0, so that's why we ignore that. And the derivative of t square is 2t, and the derivative of 2t is just 2 over the square of the denominator. Now we can simplify this expression. So in the first part, we can distribute the 6 into the parentheses. And in the second part, we can distribute negative 6t into the parentheses. So we get prime of L at t equals 6t squared plus 12t plus 6, and then minus 12t squared, then minus 12t over t squared plus 2t plus 1 squared. Now we can combine like terms in the numerator. So 12t and negative 12t will cancel each other out, and we can combine 6t squared and negative 12t squared. So we get prime of L at t is equal to negative 6t squared plus 6 over t squared plus 2t plus 1, and then squared. So this is the expression for the derivative of this given function L at t. Now we have to find the value of t for which this prime of L at t is equal to 0. So we'll sub in the left side prime of L at t equals 0, and then solve for t. So next we can cross multiply the denominator. So 0 times the denominator will be equal to 0. So we get 0 equals negative 6t squared plus 6. Now we can isolate t in this equation. So we should add 6t squared to both sides of the equation. So 6t squared on the right side will cancel each other out. So we'll get 6t squared equals 6. And next we should divide both sides by 6. So 6 is on the left side will cancel each other out. And we get t squared equals, so 6 over 6 is equal to 1. So t squared is equal to 1. Now we can change t squared to t by applying square root to both sides. So on the left side, the square root and the square will cancel each other out. We get t equals plus minus 1. Now t represents time in minutes, and we know that time cannot be a negative value. So therefore the final answer for t would be 1. So that means for this given function L at t, the derivative is equal to 0 at t equals 1 minute, because that's the given unit of time. So this should be the final answer for part A. So now we can do part B. So in part B, we have to determine L at t for the value you found in part A. So that means we have to sub in t as 1 in this function L to find the value of L at 1. So we sub in t as 1, so we get 6 times 1 over 1 square plus 2 times 1 plus 1, and we can simplify this expression. 1 equals, so in the numerator we get 6 times 1, which is 6, and then 1 square is 1, 2 times 1 is 2, and then plus 1. So this is equal to 6 over 4, which can be reduced to 3 over 2 or 1.5. So this is the value of L at 1. So we are done with part B. Now we can analyze part C. Now in part C, we have to find what is happening to the level of antacid in the person's stomach from t equals 2 to 8 minutes. So now we have to here analyze the derivative of the L at t function to answer part C. Because in part C, we have to find whether the level of antacid is going up or down in this time interval from 2 to 8 minutes. Now, we can figure that out by analyzing the derivative of the L at t function and by finding out whether the prime of L at t function is positive or negative in the interval from 2 to 8 minutes. So let's start by writing the derivative of L at t. The prime of L at t, we found it to be negative 6t squared plus 6 over t squared plus 2t plus 1 squared. Now we have to analyze this derivative over the interval that t is between 2 and 8. Now we can see that for all t values from 2 to 8, the denominator will be positive, because for any value of t we put in the denominator, the square will make it a positive term. And in the numerator, for any value between 2 and 8, the numerator will be a negative value. Because if we sub in t as 2, 3, 4 or any number between 2 and 8, the negative 6 times that t squared will be greater than 6. So as a result, we'll end up with a negative value in the numerator. And the denominator will always be positive in this interval. So as a result, so the prime of L at t will be a negative value in this interval. And we know the derivative of this L at t function represents the slope of the tangent to this function L at t. And if the slope of the tangent is negative, that means the tangent to the function is sloping downwards from left to right. So as a result, this means that the L at t function is a decreasing function in the interval. That means the value of L decreases as t increases from 2 to 8. So that should be the final answer for part C. So we can conclude the level of antacid is decreasing from t is greater than equal to 2 and less than equal to, because L at t is a decreasing function in this interval. So there is a very important concept we need to understand and memorize about analyzing the behavior of a given function in terms of whether it's increasing or decreasing by analyzing the sign of the value of the derivative of that function in that interval. So this should be the final answer for part C. So I hope you'll find the video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.